Another one. Here we go. No time to rest, Baba. Let's go. So this time, what is given to us? We are told that RUST is a cyclic quad. RUST is a cyclic quad. Let's go and indicate that cyclic quad. RUST. Here is our cyclic quad, touching 4 points. That's the circumference. Right. And then O is the center. Okay, we have a center, right? We have a center. There is O, the center. And TP is equal to PS. TP is equal to PS. Let's go and indicate that. There is TP is equal to PS. Okay, good. All the information that is given to us, we are going to need it when we are answering the questions. So we are going to apply. 26.1. T2 is equal to X. Where is T2? There is T2 is equal to X. Find 4 other angles that are also equal to X. Quickly. First nje. Lasoqala khona lo S3 nje. S3 nje seziyasuka. S3 is equal to angle T2 and they are equal to X. How come? Angles opposite equal sides. Which are those equal sides? TP and SP. Go and check on that. You need to have that because of the information. So it's angles opposite equal sides. Right. So this is X now. This is X. Right. Let's go for another one. Oh, we have what? We have a cyclic quad. Do we have exterior angle of a cyclic quad? Yes, these two are exteriors of a cyclic quad. T2 is an exterior because this line is straight and forming an exterior for the cyclic quad RUST. And also this one is a straight line passing by S, forming an exterior angle for a cyclic quad RUST. Okay, which means S3 is equal to angle URT. Let's go. So angle URT is equal to angle S3 and they are equal to X. How come? Exterior angle of cyclic quad. Cyclic quad. I don't have to finish that up. Right, you know the story. So this one is equal to X now. And then again, this one, U. Okay, the entire angle for U, or let's name it properly, RUS, is equivalent to T2 and they're equivalent to X. How come? Exterior again. How many? 4. 1, 2, 3. Okay, let's go for the last one. So this one is X, this one is X. Which one can we go for now? Which information we haven't used? Right, so now opposite angles aren't gonna work. Again, exterior, or we can use vertically opposite. Check there, T4 is an exterior because we have a straight line passing by T. And also T4 and T2, they are forming an X. Can you see that X? There is your X. So we can have vertically opposite. So T4 is equal to T2 and they're equal to X. What's the story? Vertically. The reasoning behind vertically opposite angles. Just like that. Right. I hope we're fine now. I hope we're fine with that. We're done. So 26.2 now. Prove that RU is parallel to ES. Where is RU? Let's go and highlight. RU and ES. Let's go and highlight. RU. There is RU. There is RU. And then ES. Where is it? Now it's complicated. It's complicated. Yeah, looking clean now. Let's put the X's just just to not forget about it. Right, so now we're supposed to prove that these two parallel. How are we going to prove it? We should prove by corresponding. Is it gonna work? Yes, corresponding will work. Corresponding will work. Just notified. Just got notified with nje. Straight up. Corresponding is gonna work because why? This is equal to x. This is equal to x. Hence these two corresponding. And stay corresponding? They are. Let's go. S3, angle S3 is equal to angle RUS, and they are equal to X, Y. It's proven. It's proven. So, what does that mean? That means, therefore, RU is parallel to ES. How come? It's because of corresponding angles being equal. Just like that. Right, 26.3. Quick. 26.3. Now we know we have parallel lines. Let's go and highlight on that. Let's go and indicate that. Ukuthi laba ba parallel. These two. 1, 2. Because I'm sure whatever you have just proven from the previous question, you are going to use it on the upcoming questions. Okay. Right. So 26.3. Find the magnitude of O1. Where is O1? Let's go and check on O1 and highlight it. There is O1. The magnitude is just an angle. Find the angle of O1. There is O1. And then what is O1? O1 is angle at the center. Right? O1 is angle at the center. And then you know the story. Angle at the center is twice the angle at the circumference. Is that going to work? Yes, it is going to work. Because U is the angle at the circumference. There is angle at the circumference. There is angle at the center. Which means angle O1 is equal to 2 times angle U, which is 2 times X. That means O1 is 2X. We're done. 26.4. Prove that ROSP is a cyclic quad. ROSP is a cyclic quad. How are we going to prove that ROSP is a cyclic quad? Let's write 2x here. 2x. ROSP. Okay, let's go and highlight that. ROSP. Oh, okay. Here is it. So how are we going to prove that we have a cyclic quad there? Opposite angles of a cyclic quad are supplementary. Are they supplementary? Not yet. So we have to work on that. So which one can make it easy for us to prove that they are supplementary? Because exterior going to be easy? Because we have to prove that S1 is also equal to X. Is that going to be easy? I don't think so. I don't think it's going to be easy to prove that one. But I think opposite angles of a cyclic quad, it's going to be easy because this one is 2x. Can we work out the angle of P? Yes, we can work out the angle of P. So angle of P is equal to 180 degrees minus x minus x. How come did I get to that? Sum of angles of a triangle. Remember, we are focusing in triangle SPT. SPT is the one that is my triangle of interest now. Okay, now it's 180 degrees minus 2x. So P, this one is 180 degrees minus 2x. All right, so what does that mean? Now angle P plus angle O1, they should result to 180 in order for us to confirm that they are supplementary. Are they giving us 180? Let's go. 2x plus 180 minus 2x. 2x cancels this one. The final answer is 180. Therefore, Therefore, ROSP is cyclic quad. Why? Opposite angles are supplementary. Just like that. Let's go for another one. 26.5. If ROSE is a cyclic quad, now it's given to us that we have a cyclic quad. If ROSE is a cyclic quad, let's go and highlight. So make use of your highlights and fits. In order for this thing to be much easier for you, you have to highlight. You have to highlight. ROSE. You see, even myself, I'm highlighting just to make it easy. So why not go for highlighting? ROSE, if this one is a cyclic quad, prove that ER is equal to ET. So here is ER. Supposed to prove this one is equal to this one. They are not yet equal until you prove they are equal. So how do you prove they are equal? The angles that are opposite these lines, they should be equal, or these sides, they should be equal, which means this and this, they should be equal. All right. Now, how are they going to be equal? Now I have to check if I can be able to make R3 equivalent to X. Is that going to be easy? I don't think so. Okay. Now, what can I do with E, with angle E? Oh, angle E can be equivalent to 180 minus 2x. Remember, opposite angles. Now let's go. Angle E is equal to 180 degrees minus 2x. Why? It's opposite angles of a cyclic quad. Opposite angles of a cyclic quad. I don't even have to finish up on that one. Oh, come on, vet. Right, so which means now angle E is 180 minus 2x. Okay, remember we're trying to prove that this one is equivalent to x. So how do we prove that? Now in triangle ERT, what is happening? In order for myself to work out angle R2, I'm gonna have to work out 180, because of sum of interior angles of a triangle is it's 180 minus x, this one, okay, minus x, and then minus the 180 minus x up here. 180 minus x that we have just worked out, 2x, sorry, 180 minus 2x that we have just worked out up there. So 180 minus 2x. So 180 minus x, and then this is going to be a negative 180, so it's going to cancel out because this is going to multiply here, and then this is going to multiply here. It's going to be a positive 2x and then minus x, that is x, which means R3 is equivalent to x. R3 is equivalent, angle R3 is equivalent to x. So now R3, if it's x, and then T4 is x, that means these angles are equivalent, and then therefore RE is equal to ET. The reasoning behind that is what? Equal angles subtend equal sides or equal lines. That is that. Right, let's go for prove that RSPE is a cyclic quadrilateral. RSPE. Oh, my thing now, it's rough. It's rough. Right, let's go and highlight RS P E. You see that? Oh, which means now we have to prove that this one is equivalent to this one. Remember, we know that this one is 180 minus 2x. It was 180 minus 2x, yeah. It was 180 minus 2x from what we have worked out before. And then also this one is 180 minus 2x. Then you'd say angle E there is equivalent to angle P. And then it's proven because they are both equal to 180 minus 2x. And then after that you can then say, therefore, RSPE is a cyclic quad. Why? It's converse of angles of angles in the same segment. Yeah, converse of the same segment. Why is it converse? Because now hypotai nje. You can make use of hypotai to prove a cyclic quad. There is hypotai. Just like that. Away.